by hand. We'll start by saying that F1 is already in Cartesian form, and it's of course written as 75I plus 30J, and the units are pounds. Now F2 we'll say is down here, and we can write F2 in Cartesian form as saying 60 times cosine of 60 degrees in the I direction, and minus 60 times sine of 60 degrees in the J direction. That works out to be 30I minus 51.962 J, and the units are still pounds. Then we'll make this one over here F3, and F3 can be written as a unit vector here. So we're going to write it as the magnitude 40 pounds times the unit vector, and that's going to be minus 3I minus 5J divided by the square root of the length 3 squared plus 5 squared. That works out to be minus 20.58I minus 34.30J. The resultant vector is the sum of F1 plus F2 plus F3. And these of course are all vectors, and we're just going to add up their I components. Adding up 75 plus 30 minus 20.56 works out to be 84.42I. And then adding up their J parts, which is 30 minus 51.96 minus 34.3. This works out to be a minus 56.26J in pounds. To find the magnitude of the R vector, R without the arrow on top is equal to the square root of the component squared, 84.942 squared plus 56.26 squared, and that works out to be 101.45 pounds, the resultants of adding 1, 2, and 3. The angle that the resultant makes is equal to the inverse tan, arctan, of the components minus 56.262 divided by 84.42. That works out to be minus 33.68 degrees. So we can express R as a vector in polar form as 101.45 pounds at an angle below the x-axis of 33.68 degrees. That's all.